Every computer science student learns the waterfall model. It is taught as the most logical, easily understood framework for building software. Yet modern tech companies actively avoid using it. Here we have two side-by-side flowcharts that show why. On the left is a college library management system. The features, books, students, issuing, returning, are fixed. On the right is a new social media app. The features are chaotic, shifting from chat to stories to complete redesigns based on rapid user feedback. The waterfall model operates like a strict mathematical algorithm. It assumes project requirements are absolute constants, not variables. To understand exactly where this model fails in modern development, we first have to examine its strict, unyielding execution. The process is broken into distinct phases: requirement analysis, design, coding, testing, deployment, and finally, maintenance. This animated diagram maps the cascading, one-way sequence of those phases. Notice how the progression only flows downward. The execution pointer cannot move to the next phase until the current one is exactly 100% complete and locked in. This forced one-way sequence is the exact mechanism responsible for the model's greatest strengths and its fatal vulnerabilities. This split-screen matrix maps software phases directly to a cooking recipe: wash, cut, cook, and serve. The sequence creates simplicity. Because every phase has a defined deliverable, managers track progress with absolute certainty. A phase is signed off or it isn't. By locking in all requirements at the very beginning, organizations can calculate highly accurate estimates for the time, budget, and resources they will need. Waterfall thrives exclusively in environments where project variables are known on day one, and predictability is the highest priority. But that rigidity creates a massive weakness, an inability to adapt to changing requirements once development begins. This architectural blueprint illustrates the problem. Imagine finishing construction, and then the owner asks to move the kitchen upstairs. That single late-stage change forces cascading alterations to all the underlying foundation and plumbing you already built. This branching hierarchy shows the software translation. One flawed requirement multiplies into 10 flawed design nodes, cascading into hundreds of bugs during testing. Because deployment happens last, the customer remains blind for months. If rejected, immense effort is entirely wasted. The strict linear nature of waterfall creates a catastrophic risk multiplier. If your initial assumptions prove to be incorrect, the cost of fixing them grows exponentially. These three project nodes must be categorized by their likelihood of changing requirements. The tax system and defense software route into fixed variables due to strict regulatory rules. The AI startup routes into dynamic variables because its features rapidly mutate based on user feedback. The anticipated rate of change, rather than the raw size of the project, is the definitive variable in deciding whether to deploy the waterfall model. Waterfall is like taking a university exam where you study the entire syllabus and only find out your grade at the very end. Modern development is like having a teacher check your understanding after every single chapter. For waterfall to succeed, the environment must provide stable technologies, require heavy documentation, and guarantee an unchanging scope. This master summary table juxtaposes the model's profile. On one side, systemic advantages: predictable planning, rigorous documentation, and clear management. On the other side, critical disadvantages: complete inflexibility, late testing, and compounded risk. This leaves us with one unresolved complication. How can developers build a system when the customer themselves cannot articulate exactly what they want at the beginning of the project? That specific point of failure forced the software industry to invent the prototype model, a method that abandons rigid planning in favor of early, rapid experimentation.